Okay, sure. Yeah, let me introduce myself again. My name is Leon. Yeah, let me go back to the first slide. So my name is Leon. I'm from ThinkMo. Today I'm going to share about the routing foundation or fundamentals and the static route. So this is my agenda. Before I can introduce the routing fundamental, I'm going to talk about the data forwarding process. So this is the knowledge for you to better understand how the data being forwarded from the layer 1 to layer 7. And the second part will be the routing fundamentals. In this part, I'm going to introduce the routing table and how the router is going to select the best route for the packet forwarding. Okay, and the last piece, I'm going to talk about the static routing, which is very important, the routing protocol in our routing fundamental. Yeah, I'm going to cover the demo for the static route. So just keep in this section until the end. So you will see the demo and how to configure the static route. Okay. So first part, data forwarding process overview. So in your mind, do you have any concept of how the data are being forwarded if the computer A want to talk to computer B? So do you know how exactly the data being flowed over? So what you know that if I send a message, like for example, you're going to send a message to your girlfriend, you use your Facebook chat, how the data being forwarded, right? As a network engineer, you need to know how the data being forwarded at the back end based on the OSI model. Okay, so before that, I'm going to review the OSI model. So what is the OSI model? It's an open standard interconnection model, right? It's a reference model for different vendor, like for example, the computer vendor, the network device vendor. They're going to refer to this model to produce their product in order to communicate to other vendors' product, right? So this is a reference model. So here you will see that actually we have two reference OSI model here. One in the left, let me show you using a pen. So we have one OSI model here. We have the other one here. What does it mean? So here we're actually representing one host. Let's say this is a host A, or is a computer A. So this one is a computer B. So according to the OSI model, the first layer is physical layer. The second layer is data link layer. Network layer is the third one, and then followed by transport layer, section layer, and the presentation layer, application layer. So this time, can you remember this OSI model 7 layer? If you can, give me a thumbs up. Nobody can remember. Or have you learned this before? If you have learned this before, you also can give me a thumbs up also. Just use the emoji. Okay. Yeah, so for this OSI model, it's very important for us to remember or to refer to some of the network communication. So let me introduce a way for you to remember this 7 model, the 7 layer of the model. For example, this physical data network transport. So you don't need to remember it so hard. So you just, for example, you can use an easy way to remember it, like please do not throw sausage pizza away. Then you can remember. Okay, let me repeat again. Please do not throw sausage pizza away. So in this way, you can remember the 7 layer of the OSI model. Can you get it? If you can, give me a thumbs up. Or you cannot. So that means you still cannot understand what is this mean. Okay, let me clear it. How come I can't clear? Okay, thanks. Thanks for responding. Let me erase everything. Okay. Yeah, the way to remember it, actually, you can also maybe use your own way to remember it. So now today, the most important part is not to remember this OSI model. I'm going to utilize this model to tell you how the data being forwarded from one host to the other host. So just now, as I mentioned, this one is the host A, this one is host B. Let's say host A is going to send a message to host B. So the data packet will be actually sending out from the application layer. So from section layer, presentation layer, and the application layer, this one is combined as application data, right? So you will see my arrow is from top to the down. So from the sender, the application data will be start to encapsulate from the transport layer and then followed by the network layer, then go down to the physical layer. If the physical layer, you know, is actually the computer's network adapter. So this network adapter will connect to the other network adapter. For example, they are direct connected. Of course, in between, we will have many network device in the cloud here. So here we just assume they are just direct connect with a cable. So the traffic will through the physical layer, use the cable to connect to this side. So from here, the packet will be actually from down to top. It will become a decapsulation. Here, we are use the word as an encapsulation. Here, we actually use it as a decapsulation. That means it actually is assembly the packet from the sender A. When you reach to sender B, start to assembly and decapsulate the packet. So it will follow by physical layer, data link layer, network layer, transport layer, and until the three layer is actually original data comes to here. Yeah, this is the overview of the data forwarding process when the user, no matter the user A is sitting in which location, the data will follow this way. The application data will be encapsulated and then sent over through the physical layer. It will become this, we call it bit. This bit will become 100101, this kind of bit, and being forward over to the other side, host B. Host B receive it, you will start to do the decapsulation. And until this place, it will become application data. And the host B is able to read the application data. So I will stop here. Any question? Any question? If not, I will just go to the next slide. Okay. Sorry. Okay, I need to erase. Okay. Okay, next slide. So here we have a host A. It's going to access the web server. And this web server is hosting the web page, which have the address is www.thinkmo.com. Okay, so host A is going to access this web page. The first step he's going to do is he will be opening a browser. There is an address bar here, right? So the host A will actually key in the so-called URL, or you can call it a web page address, www.thinkmo.com, right? So after keying this URL, what will happen? Because in the host A, the computer won't know where is the www.thinkmo.com or what does the www.thinkmo.com mean, right? So in this situation, the piece host A will start to do a domain name translation. So which we will have this DNS server comes in. So host A will start to look for the DNS server to translate this URL into an IP address, which is this IP address, right? So this is the initial part that host A is going to do. Let me repeat again. Host A would like to access the web page with the address www.thinkmo.com. First step, the host A need to open a web page browser, key in the URL. After keying the URL, the computer will start to do a DNS resolve, right? So the DNS resolving is just need to translate the URL or this domain name into the IP address, which is 172.16.10.1, right? So any question until now? If no question, you can give me a thumbs up also. Okay, no question. No question, I'll just move on. Next one. So the packet will be start to be encapsulated from the TCP layer, right? As I mentioned just now. So in the TCP layer, the TCP header will include this source port. This source port is actually a TCP port, which is included in the TCP header. So you have source port and the destination port included in the TCP header. So as you see, the TCP header will be inserted in front of the data packet. So it becomes a data segment. So this is called the first encapsulation. Okay, so with the source port and destination port, the host A actually define what kind of protocol is going to access. Here we will have this AT. TCP AT, we are referring to HTTP, right? HTTP. Okay, so here we mentioned that when the host establish a TCP connection to the destination, it starts to encapsulate the application layer data. Yes, so before the encapsulation, host A will need to build up a TCP tunnel to the website, the web server. So if you know that the TCP three-way handshake, then you will know what happened before they can encapsulate. If you don't know what is the TCP handshake, and you can just follow us in the next, and I think next class we will have this lesson to tell you what is the TCP handshake. Okay, that is very important for the application to actually form the TCP section, and then in order to forward the traffic or transmit the traffic. Okay. The next, it will be encapsulated by the network layer, which is layer 3 with the IP header. So what is inside the IP header? We have source IP address. Here is the 10.1.1.1. The destination address, which is the 172.16.10.1. So here, how can we know the destination IP? Because the source IP, of course, it will be host A's own IP address. So just now, because of the DNS resolving, right, we know that the destination IP address is 172.16, right? So it will be included into the IP header, right? So it will encapsulate in this stage. So this stage is happen at the network layer at our OSI model layer 3, right? Until now, we are still going from the top to down, right? Okay, next. As long as the host A already know the destination IP address, it will start to look for the routing table inside the host A. So the routing table, we will introduce the detail of the routing table in the next slide. So here, we're just telling you that the next step, host A is going to look for the route to going to the destination. So as you know that there's no specific route going to the 172, this 172.16.10.1 is not included in the routing table, but we can see the default route here. So as we know, the default route is actually referring to the gateway. So host A will start to look for the gateway's IP address. Okay. Just give me a moment. Until now, do you have any question? Maybe you can let me know at the chat. Give me a thumbs up if you have question. If no question, I will just continue. So just now we know that host A is going to look for the gateway, which with the IP address is 10.1.1.254. So it will actually look for this IP address, but it will start to look for the MAC address because we actually it's already know the IP, but we don't know how to reach to this gateway. So it will go down to the next layer, which is the layer 2 data link layer. In the data link layer, we actually utilize the MAC address, which is the physical address here. So to map the IP address to the MAC address, in the host A, the PC, there is a up table, which is the ARP table. So in the ARP table, you can use this command in the Windows up-A. You will see the IP address and the MAC address, the mapping here. So in here, we will know the MAC address and the host A will be able to send the packet based on the layer 2 MAC address here, sent to the gateway. Okay, so here we also mentioned if there's no MAC address being found in the up table, so host A will actually send the up request or to the network. So most common will use the broadcast to send all the requests to the whole layer 2 network until it find the MAC address of the destination IP address. Okay. Okay, next is the Ethernet encapsulation. As I mentioned, right, after the host A found the MAC address of the gateway, here's a gateway, so it will include the gateway's MAC address into the destination MAC address, and it put its own MAC address as the source MAC address, and encapsulate using the Ethernet header. So until now, we actually see a few encapsulation here. We have TCP, we have IP header, we have Ethernet header here. So until now, we are still from the top to the down, as I mentioned in the first slide. From transport layer, network layer, until data link layer, we will encapsulate the layer 2 header, which in this stage, we actually call the packet, the whole packet as a frame, right? Okay. So what does it mean that if why the host A need to put this destination MAC address and the source MAC address into this header? So this is used to tell that tell the next hop of the receiver that where is the packet is going to send. So I will discuss this in the later part. So next, we will actually reach to this physical layer after this encapsulation. As I mentioned, when the packet reach to the physical layer, it will become bit, which is the 010101. So it will be sent over to the physical layer using the cable, physical cable. Okay, so this is the whole process of the packet forwarding from host A sending to the web server. Any question? You can raise your question now. Do you have any question? No? No, then I will just go to next. So I assume you all understand the process, right? So here we are going to talk about the routing fundamental. So starting, we'll talk about what is routing. So here we have a definition for the routing is the process that routers use to determine the path that the IP packets should take over a network to reach their destination. So you will see here, routing is used for the routers. So the routers, what is a router? Router is a network device, usually it's a layer 3 device that used to forward the packet in the network. So it's to help to forward the network. So just now we actually, when we talk about the data forwarding process, we actually noticed that host A also has the routing table, right? Have the routing table, which is a routing function. So actually, normal PC can also act as a router if the PC used for forwarding packet. Okay, so if you are using, like, for example, a Linux server in between to doing the packet forwarding, the Linux server can be a router as well. Okay, so this is the router diagrams, so-called the icon inside the network diagram. It's typically using this kind of symbol. Or if you can draw from the paper, usually we're drawing like this. Okay. So let me repeat again. The routing is the process that the router used to determine which path to forward the packet to. So the process is called routing. Okay. So with the routing, we need to introduce the routing table. So a router will have a routing table to record all the route that the router learned. So a route is just like where and how the router is going to send the packet to the destination with a specific next hop. Okay, so for here, the routing table is actually a address on how that, for example, the routing table will include the destination IP address, and the next hop for forwarding the packet to the destination IP address. So let me tell you a story here. For example, we have people here, this guy. Let me name him as Peter. Okay, I just put Peter. Okay, Peter is going to send a mail. In nowadays, we seldom use mail, but in a long time ago, before the email, people still use mail. So Peter will actually write a mail and put it into an envelope, right? So on top of the envelope, Peter will need to write down the name, so-called the receiver, right? The receiver name. And also Peter will need to write down the address that this receiver living, right? And also Peter will need to write his own address inside the envelope as in case the letter being cannot be delivered to the receiver, right? So after this, then Peter will actually put this letter into the letterbox. So it will wait for the postman to pick it up, right? So after that, the postman will start to pick up the letter in certain time as daily. So they pick up the envelope. It will look for the destination and look for the receiver's name. actually, postman doesn't need to know the name of the receiver. You will just need to look for the destination address. So that according to the destination address, the postman will start to send the letter to the next step. If the user or if the receiver is inside the area of this postman in charge. For example, this postman may be just in charge for a certain area of the delivery. If the receiver is staying within the area, then postman will just direct send to the receiver, right? So if the receiver is staying further than this location, so the postman typically will send to another station, post station. So another postman will, or the some kind of truck will help to deliver to the other station which near to the receiver. Okay, so this is kind of the mail being delivered. So here as a routing, we are actually doing the same thing. The router is actually having the address where the receiver or the destination is located. So when the packet comes to the router know how to forward it to the next step. It's just like this postman pick up the email, the mail, it will actually give it to the station, and this station will have the other postman to forward this one to the other station. It's just like this way. You just understand in this way. So router is just like the postman is like forwarding the mail to until forward to the last receiver. Okay, so this routing table is actually store all the path that router can use to deliver this message to, or deliver this packet to. So for the routing table, we have two ways to configure. One is the manual configuration. So network administrator can just based on the requirement to configure static route into the routing table. So the router will actually have the static route. So we are calling static routing. Next, in the next section, we are going to talk about this. And the other way to have the routing information is the dynamic routing, which router will run the dynamic routing protocol, for example, the OSPF. So for the dynamic routing protocol, all the routers, they will actually share the routing information to each other with some of the mechanism. Okay. Any question for the routing table and the routing? Okay, this is how the routing table looks like. From the router, when you show IP route, you will see the routing table here. We have the destination network and then the next hop here. So let's introduce, like, for example, this O, it means the OSPF. Here we have some definition to know that what does the O mean. So C means it's connected network. Okay, so D means it's a EIGRP network. So this EIGRP OSPF dynamic routing protocol. This C is connected. The L is a local network. So local network is actually similar to the connected network, which is direct connected. Direct connected. Okay, so you see this S is referring to a static route. Static route. So static route means that we network administrator manually configure in the router. So it will actually goes to the routing table after you configure. Okay. So packet with a destination network that does not exist in the routing table, the router receive the packet, will check the destination IP address. If the destination IP address is not included in the routing table, we will drop the packet. Okay. So here, routing table, for example, we have this O. Remember, O is OSPF, is a dynamic routing protocol. Here O included the 12.1.1.1, which is the next hop IP address. Next hop IP address. And this interface, fast Ethernet 1/0 is the outgoing interface for the packet being sent out. So here we have seen that two generation method for the next hop IP address, which is the we configure manually within static, or we automatically generated using the dynamic routing protocol. This is the one of the OSPF route. And the next also we continue with this OSPF route is O means the LAN through the OSPF. And 1.1.1.1 is the destination IP address. Okay, that means the route is learned via the OSPF routing protocol. It learned that how to reach to this 1.1.1.1 using the next hop 12.1.1.1. And the outgoing interface is a fast Ethernet 1/0 for this local router, right? So this route has been learned for 59 seconds. And this 110 is the administrative distance, which actually define the priority of the routing protocol. Later we will talk about this. This is used for choosing to select the route by the router. And this 2 is the routing metric or the cost for the routing protocol. So dynamic routing protocol use the routing metrics to select the better route. So far, any question? Do you have some picture of the routing table now? Okay, no problem. Yes, okay, thanks. If you guys can give me a thumbs up, it will be much better. So I will know that I'm not talking to the air, right? Okay, thank you. Well, invisible also showing yes. Thank you. Okay, next we will talk about the route selection. Because of the routing table, the router will learn a lot of route from the neighbor router or from other router within the network, or you will configure by the network administrator. All these are static route or the dynamic route. It will be stored in the routing table, but some of the route will have actually same destination but different next hop. In this case, router will need to determine which path is my best path to go through to go to this destination, right? So for example, in this diagram, my router A is the source router. It's going through this destination router, which is router B. For example, I have some network behind my router, right? So my router A will need to choose whether I need to go to router B or I need to go through router C, or I can actually go to both paths I can reach. So this is the job router have to do, right? So we will have some mechanism to define that, like how the router is going to select the route. Okay, there are 3 major things that we need to talk about here that router will use this to choose what is the better path for. Okay, what's your question? Yeah, I just stopped for a while. Let's see the question from my name a bit. John. Please tell me your question. How exactly does all this work? Which part? How does it work? So just now we talk about the data processing, and then we talk about the routing table, right? So now we are talking about the router is going to select the better route, right? So the reason why I was talking about the data process is because if I immediately tell you what is the routing and what's the router, and you won't know why the packet actually being sent to the router, right? And why the router need to forward the packet, right? It's because when the client A or the host A is trying to access the web page, how the packet is going to send over to the other end, right? So router is just part of the path that help the packet being delivered to the other side. So until now, we're actually talking about how the router is going to select the path to forward the packet from one router to the other router, or actually just sending it to the destination receiver. Okay, so here we have three conditions to define how the router select the best path. So the first part is the administrative distance. This one, as I mentioned just now, is actually define the routing protocol priority. That means different routing protocol, they will have different AD. We call it AD value, which is the administrative distance value. So the value smaller, it will be better, right? So here, static route, we are actually having AD value, which is 1. So usually static route will be more preferred than to the dynamic routing. Yes, please, John. I'll mute you. Okay. Let me try whether I can unmute you. Okay, you can talk. Oh, not you. How come your name is so? Oh, sorry. You. Okay, sure. Thanks, John. Okay, John, you can ask.
I like watching videos of black men shaking their booty cheeks. I don't know why, but when I click on a video and see a black man shaking his cheeks, it just makes my mouth drool, and I start dancing with the black man as well.
Okay. I think he's asking invalid question. Okay. If you have question, I think you can just better type in the chat. I won't unmute anyone from now on. Okay. Yeah. So we continue with our question. Okay. With our lessons. So the second condition that router used to select the route is the metric. So if you are using the same routing protocol, for example, the dynamic routing, so between the dynamic routing, the router will compare the metric to define or to select which is the better path to forward the packet. So the metric, usually the smaller, the better. Okay. So at the third point, if the same routing protocol, they are having the same cost of the route, so the router will do the equal cost route sharing. Okay. Sorry, let me just move him. Okay. Just give me a minute. Let's clean up something. Okay. Yeah, let's continue. So equal cost routing means that the router is having two routes with the same cost. So the router will use the two paths to do the route sharing. Okay, later we'll talk about this. So until now, any question? I need the valid question. Do you have any question? If not, then I will just continue. Yeah, let's go to the administrative distance. So here we are having the value of different routing protocol. For example, here, oh, sorry. So here we have a connected route with the administrative distance, which is the AD value with 0. Do you remember just now we mentioned the smaller, the better, right? So the connected route will always be the best. For example, the RA, the router A, and this router, they are having the connected route, which is this route. So this is always the best. For example, if the router A needs to go to the 30.1.1.2, the IP address, it will always choose the direct connected route. Okay, so this is the connected route with the AD 0 because the 0 is the lowest, so it will be always preferred. The next one, OSPF with the 110 AD value. And the static route, just now I mentioned, with 1. Okay, EIGRP will have 90. All this value is the default value of the routing protocol itself. So you can actually configure in the router to make the OSPF protocol using different AD value, so that it can have different AD value to actually perform other way of the routing selection. That will be in the advanced course if you are interested. Yeah, RIP is also available. Yeah, so here we don't use RIP as a example because I think RIP now is not so common to use. Of course, RIP have even a higher AD than this OSPF here. Yeah. Yeah, you have a good point here. RIP is also one part of the routing protocol. Yeah, here we're actually showing the example to compare the different routing protocol with the AD value. So remember, the lower AD value will have the better, means that it will be more preferred by the router. Okay, so next, we will compare if they are using the same routing protocol as the diagram here. We're actually using OSPF. So it will compare the routing metric. So for the OSPF, we are using cost for the metric. So some of other routing protocol like sorry, I don't know how to pronounce your name, but you just now mentioned about RIP. RIP is using hop count as a metric, and the bandwidth will be used by the OSPF as well, and also the EIGRP. And we have the delay for EIGRP. Cost is mainly used by OSPF. All these cost, load, or reliability, they are actually used to measure the metric of the dynamic routing protocol. So router will base on all this value to define what is the metric of this routing. So it will select the better route based on the metric value. So still the lower, the better. Okay. So for example, in this diagram, the cost 10 is compared to cost 1. Cost 1 will be better. It will be selected by the RA to go through this way. But of course, the whole path, we need to add on all the costs together in order to select the route that going through the destination here. In this diagram, let me repeat again. Okay, let me repeat again. For example, the router A need to go to the destination 10.1.1.0/30, this subnet. It has two routes. One is via this way. One is via this way. Okay. So for this way, we have total cost 10 plus 10, which is 20. So here we have total cost is 1 plus 1, which is 2. So 2 is lower than 20. So this path it will be selected by the router to go through the subnet. Okay, any question? No question. Yeah, for the RIP, right? RIP is one of the routing protocol. If you want to know the detail of the dynamic routing, we have another class, or next class we may maybe talk about this dynamic routing. For this class, we actually talk about the routing fundamental and also the static route first. So if you are interested, please follow us and go maybe join our next class. Okay, the other one is the load sharing. So for example, router A going to destination A.A.A have the same cost of the route. So we have two routes here actually being configured in the routing table. It will show that a static route to the A.A.A as the destination. We have two next hop and with the same metric here, 1, 1. Actually here 1 is the AD value, which is the static route's AD value. And you can type your question here, I can answer you. Yeah. So static routes support equal cost load sharing to the same destination. Yeah, based on the AD, OSPF will be, no. Based on the AD, EIGRP will be more preferred. If you are having two type of routing protocol, for example, OSPF and EIGRP, right? Router will compare the AD value instead of the metric. So even though you configure the metric in the OSPF, for example, you tune down the cost to become very low, like 1. So you will still prefer the EIGRP. So let's go back to this page, this slide. EIGRP is having 90. OSPF is having 110. So EIGRP is always being preferred more than this OSPF. EIGRP is mostly used in Cisco router. Yeah, EIGRP is actually Cisco's own protocol. That means other vendors router or it doesn't support this protocol. So if in the network environment, they only have Cisco router, so EIGRP may use as a better choice because EIGRP, the conversion is much faster than OSPF. But usually a lot of enterprise, right, they don't just use purely Cisco device. They usually will mix some other vendors to connect to Cisco router. So it will become OSPF is the better choice. Okay. So of course, you can actually build a network that mix EIGRP and the OSPF. And then the routing table, you can do a redistribution for the routing. You can redistribute the EIGRP route into the OSPF, and you also can do the OSPF route redistribute into EIGRP. That is no problem. You can actually mix with the two routing protocol. But this will actually introduce a more complex design in your network. So in most of the enterprise network, we actually use more like purely OSPF, or we can combine with the static route. Okay, did I answer your question? Okay, until now, we actually talked about the 3 conditions, right? Any part of network can we override to select OSPF over EIGRP using menu configuration. You can actually configure the OSPF to have a lower AD value. You can do that, so that you can the router will choose the OSPF then actually prefer the OSPF than EIGRP. Yes, you can do that. Even by the static route, you can also change the AD value to become higher Like the default is 1, you can change it to be very big until it's a lot higher than the dynamic routing. And I will talk about this later also. Okay, thanks for your question. Next one, we talk about the longest mask matching principle. This is also another part of the route selection for the router. So as you can see here, the same network, we can actually have a different sub-network. For example, if you learn the IP addressing, that even 1.0, you can use /24, /25, /26, or /27. So for example, the IP address with .1.1 is actually belongs to all of this subnet, right? So for example, I have one router. I'm going to send a packet to this 192.168.1.1. So which path should I choose in this case? Should I choose .1.1 as the next hop, or .2.1, or .3.1, or .4.1? Anyone can answer this question? The first one. Okay. Any other question? Any other answer? So you can look at the title here, longest mask matching principle. What is the longest mask? So that means if you are having this IP address like /27, what is the /27? Can you tell me the subnet mask /27? It will be 255.255.255. This one is it will be 22224, right? This one is the subnet mask of this /27, right? If you have learned the IP addressing, right? So this one, it will be 255.0, right, for the /24, right? So this one means it's more specific route. It's the longest mask, means that this subnet mask is longer than this .0, right? So this one will become better choice. So that means it's more, the route with more specific, it will be better than this shorter mask. You get what I mean? So here, longest mask meaning that more specific route will be preferred than the less specific one. Okay, so for example, you have the route that actually the host IP, which is 192.168.1.1, with the subnet mask is 255.255 until the end is 255, which is the host 255.255.255.255. So this is the host route. So if you are using the route that point to the host IP address, it will be more preferred than you using /24 as a next so-called the destination. So here we're actually having this longest mask matching principle here. With the longer mask will be more preferred if you are having this kind of network in your routing table. The router will prefer the longer mask. Okay, yeah, I'm just doing a summary here. So when the router actually send the IP packet out to the other router, it will actually send out from the outgoing interface and look for the next hop, which is 20.1.1.2. And then when the router need to send this packet to the next hop with the IP address, it will need to refer to the destination MAC address for the layer 2 part, right? So after router A get the ARP or the up resolve or the up table, we can look for the next hop's MAC address. it get the destination MAC address information, it can send the packet to the 20.1.1.2 accordingly, right? And then when router B receive the packet, it will do the same thing, look for the routing table, look for the next hop of the packet, IP packet. If the destination is going to 10.1.1.0/30, the target network, it will look for the routing table, whether this destination is inside the routing table. If in the routing table, it will just forward to this router C, for example. If the route is not inside the router B's routing table, it will drop the packet. Okay. So static route. So static route concept that we use the same diagram here, that if the router A need to send the packet to this 10.1.1.0/30, so the router A will be manually configure a route that point to the router B as a next hop with the destination is 10.1.1.0/30. So the static route is actually configured manually, which is not automatically updated. Okay, so router will prefer the static route to the dynamic routing is because the static route has the default AD value is 1. Okay, so here let me repeat again. For router A, if router A need to go to the 10.1.1.0/30, we have two ways to get the route to reach to this destination. One is static route. The other way is the dynamic routing that I'm able to learn from router B, so that I will know how to reach to this network. Or my router B will need to learn from router C to reach it. So this is called dynamic routing. But here we talk about the static route is that network administrator will manually configure how the router A is reaching this 10.1.1.0. This is called static route. Okay. So this is the configuration with the IP route command. In the Cisco's router, we use this command, and then followed by the IP address and the IP subnet, and then with the next hop or the outgoing interface. So you can just configure like this. We are using the next hop IP address here as an example. So after that, you can use show IP route static to verify the static route. I will have a demo to show this in the later part. If you have configured the dynamic routing in the same router, and the router learn the route, for example, in this diagram, right? Let me remove the. Okay, for example, my router A actually having configured one static route here with the AD metric is 1, and I also configure the OSPF here, and the OSPF help to actually router B to share the routing information to the RA that, oh, my route is to please use me as a next hop to send the packet to this destination network. So in my routing table, I will have the other route that learned from OSPF with 110AD, right? So if the static route, let's say the next hop or the static route being removed by somebody, then this dynamic route will be selected, right? Okay, did I answer your question? So if the dynamic routing is not configured here, then the packet will be dropped. Okay, let me see whether I can. Oh, I can't. Okay, next. Yeah, just now we talked about the static route configuration here. Okay. Next one is floating static route. What does it mean? Floating static route means that you can actually change the AD value of the static route that make the static route become the backup route for the dynamic routing. As just now we mentioned, right? If the router have learned the dynamic route in the routing table, and also you configure a static route in the routing table, then we can actually configure another static route with the higher AD value to become the backup route for this dynamic routing. So for example, here I have an example here that the IP route pointing to the destination 10.1.1.0 the /24, and with the next hop is 20.1.1.1. This one is the backup route for another dynamic routing. That, for example, if the dynamic routing also learning the route to the same destination with another hop, next hop, then if let's say this dynamic routing is failed, means that next hop is not working, then this floating route will take effect, because the 255 is being configured here as the highest AD value. So this 255 will be very high because OSPF is only having 110, right? So even static route is usually more preferred than the OSPF, but because of the AD value being manual configured to higher, so OSPF will still be preferred. But if the OSPF route fail, then this static route will take effect. So this one is used commonly for backup. Okay. Sorry, I got a lot of remote control. So this is the usually mainly for the backup function. So far, any question? Bot. See how to move it. Okay. Okay. Any questions so far? Floating static route. The name for this static route is called floating static route. Floating means that in case the dynamic route fails, this static route will become the backup. Okay. This is very common use in the enterprise network that they usually need some backup if the dynamic routing fail. Okay. The other concept is default route. Default route means that if there's no more specific route being selected, then this default route will be used for the gateway concept. If router cannot find any other more specific route in the routing table, this default route will be used to forward the traffic. So this is actually to prevent the packet being dropped. If the so-called the router cannot find any route in the routing table. So this default route, the next hop is this 20.1.1.1. Oh, sorry, this 255 shouldn't be here. Okay, so this only 20.1.1 is the next hop. Okay. Okay, let me remove this. Any question so far? This is the default route we actually commonly use in the internet router. So internet router, because internet with a lot of IP address that we don't know the specific IP. So if the traffic is not inside your network, it's going to internet. So this default route usually will be used. We commonly call this as a gateway route. So that means the internet router usually is the gateway of your network, your enterprise network that going to the internet, right? So default route again is the router that last resort to use to forward the packet out. Last resort means that when router cannot find any other better route, it will choose the default route to forward the packet out, use the destination or use the next hop. Okay, any question? Default route? It's commonly used at the internet router. Okay, so if no question, I can proceed to do the demo. Any question about the previous section? Okay. No question. Okay, thanks. Let me do a quick demo here. Maybe I will just show you some of the command. Oh no, password incorrect. Give me a moment now. Just give me a moment that okay, can you see the diagram? Okay, can you hear me also? Just now I mute and then I try to find the password. So now can you hear me? Or can you see the diagram? Okay. Yeah. So let me introduce the diagram here. Maybe I will show you another diagram here with a better understanding. Okay. So for just now, the diagram is the same as this one. I have 4 router here. With the connection here 20.1.1.0/30 connect between the RA router A and the router B, and this one is the 30.1.1.0/30 is connecting to RC, and here we have another interconnection which is 192.168.2.0/30, and this one is another interconnection. I have 4 router here, but for the first demo, I will just use the 3 router on top. Yeah, here. So I will just start to configure the static route in the R1, R2, and R4. So I have R4 here. Let me show you the interface. So in the R4, I have a loopback IP address here with the IP address 10.1.1.1. I will use the loopback 0 to actually simulate the destination IP. So remember this IP 10.1.1.1 is sitting behind the R4. Okay, so R4 Ethernet 0/0, which is this. This is connecting to R3. We will just ignore for the first part. Later part we will use. 0/1 is connecting to R2, right? Okay, so we come back to R1. R1, I have another loopback 0 here, 1.1.1. I'm actually doing the simulation to have another host that connect behind the R1. So my R1 0/0 is connecting to R2. So my 0/1, of course, is connecting to R3 that we will use for another demo. R2, okay, I also have 2 interface. One is connecting to R1, 20.1.1.2. And the other interface is connecting to R4, 192.168.1.1. Okay, first of all, if R1 need to reach to R4, right, I will need to configure the static route at the R1 at the first step. So I will configure the R1. So I will use IP route followed by the destination IP address is 10.1.1.1 as the subnet mask is 255.255. Here I use the host IP as the destination, which is actually the most specific subnet here. We use host IP. So next hop, I will need to point to 1.1.2. This 20.1.1.2 is the E0/0 of R2. Let me confirm. This is R2. This is E0/0 with the IP address 20.1.1.2, right? So first of all, let me try to, maybe I just try to ping from my R2 to R1 to make sure the interconnection is okay, right? 20.1.1.1. From R2, I ping to R1. So it's working now for the interconnection. That means I can use it as my next hop to go to R4. Okay, I will configure here. So after I configure this, I should be able to see from my routing table, right? So show IP route static. So it's actually show here. So going to 10.1.1.1, next hop via 20.1.1.2. Okay, so this is the first step. So this routing table entry, this routing entry is telling this R1, if I want to go to 10.1.1.1, I will need to forward the packet to next hop 20.1.1.2. Okay, so next my R2 will receive the packet. So my R2 will start to do a configuration of the static route with the same destination 10.1.1.1. Okay, with the next hop, we should point to R4 0/1. So let's check what is the IP of 0/1. R4 0/1 is 192.168.1.2. Okay, so I will come back to R2, configure next hop is 192.168.1.2. Okay, so at this stage, first of all, I will try to ping the 192.168.1.2. Okay, it's working. For the next hop, it's working. Then 10.1.1 is already configured. Let's show IP route static. So R2 is already know that 10.1.1.1, I will need to go through. The next hop is the R4 E0/1, right? So now R2 is already know that how to reach to R4. So R4 is actually next to me. So I just need to forward the traffic to the packet to R4. Then I should be able to reach to the 10.1.1.1, which is behind R4, right? So let's try to ping 10.1.1.1 from R2. See, it's able to ping. So let me try to remove the route here. So I ping again. So it's not pingable. It's not able to reach because there's no route here, right? Because I just now removed the route. So let's show IP route again. We don't have any route without, beside this connected route or the local route. So in order to go to the destination, we will configure the route again. Okay, we protect the static route. We'll show IP route static. Okay, now it's in the routing table. Or maybe I just remove the static. You will know that actually S is inside now. Previously, we don't have this static route before we configure, right? So now we try to ping again. So now it's okay. Okay, R2 is able to reach to the 10.1.1.1, but it's not yet done because we need to make R1 to reach to. So let's see whether R1 can reach or not. Ping 10.1.1.1. No. Why? As long as R1 can throw the packet to R2, R2 should be able to throw packet to R4, right? because R2 is already able to ping 10.1.1.1. Why my R1 is not able to reach? Anyone can answer my question? This is a question for you. Now let me repeat my question again. Now, just now we already test R2 is able to reach to 10.1.1.1 behind R4. Why R1 is not able to forward the packet to R2 in order to reach to the destination? Anyone got idea? No? Okay. Maybe just because of the time. I think no, it's not 80 too long. The reason is because my R1 is able to forward the traffic to R2. No problem. My R2 is able to forward the traffic to R4, right? So the problem is that when my R4 need to return my packet to R1, my R4 doesn't know how to go to R1. There's no route in my R4, right, to the R1. But why my R2 R4 can forward back to R2? Because they actually direct connect to each other. That's why R2 is able to ping, but R4 cannot reach to R1, so the R1 cannot ping. Okay, so in this case, we will need to come to R4 to do another route. Okay, so IP route here, we will need to route to the destination is inside our router 1. Okay, with the next hop is 192.168.1.1, which is our R2's 0/1. Let's see here. Okay, .1.1. Okay, so I will just add this route inside. So I will try to ping. So it still cannot reach, right? So in this case, I will use the source loopback 0. In this case, we will need to troubleshoot, right? So R4 is trying to reach to R1 behind my R router 1, right? So with the source, which is the loopback 0 in the R4, let's see my loopback 0 is 10.1.1.1, right? In the R1, I have the route that actually pointing to the R2 as the next hop. And then my loopback is actually here connected. It's 1.1.1. What if we can configure R2 to R1? You mean the R2 to R1 is the route, right? Correct. So here we will need to have a route in the R2 for us to forward the traffic to the R1. So the next hop is 20.1.1.1. Okay. So this one is the part of the return path that my R4 return traffic sent back to R1. I will need to send back to the R2. So the R2 will need to have the route to 1.1.1 because 1.1.1 is not direct connect route, which is sitting behind the R1, right? So in my R2, I need to have additional route here. So in this case, we can try again. Now it's okay, right? So in this case, we can use the trace route to verify also. Anyone use the trace route before? Is to trace your packet that which path is going through. Okay, so from R4, my next hop will be pointing to R2. 192.168.1.1 is the next hop. And then R2 is sending 20.1.1.1, which is our R1's E0/0. When the packet reach to R1, R1 will actually forward to the loopback 1.1.1. So this is our first static route configuration. Any questions so far? So I think the timing now is a bit late, so I will just go straight to the next topic, which is the IP SLA. How many of you that hear about the IP SLA tracking? No. So it's very common to use in the enterprise network that, for example, here, if let's say you are having two ISP router, this one is ISP1, this one is ISP2. What is the ISP? Service provider, right? Service provider router, RP, RC. So we are actually from RA, which is our customer or client router, need to go to the internet, for example, is sitting behind 10.1.1.0. So if we want to go to this way, or we have the other way here as a backup path. So we can configure that in case that this primary path fail, this secondary will take over as a backup route. So here we have this track A configure here is to check the IP/SLA1 as a reachability. So what we configure in the IP/SLA1, we configure the ICMP echo. ICMP means the ping echo means that the other side 20.1.1.2 have to reply me, right? Echo reply me. So I will use my source IP 20.1.1.1 to ping this IP as a checking the reachability here. So if the reachability fail, we will actually trigger this route change. So therefore, there's a track A here. Track means that it will always check the reachability for using 20.1.1.1 to ping 20.1.1.2. If this pinging is failed, then it will take this second static route as a backup. Okay, which is this path. So what does this command mean? This command means that IP SLA will schedule this number one SLA, lifetime forever, and the start time is now. So this checking will be always on, and the start time will be now. Okay, understand? So the main purpose for this command for IP SLA is basically to track the reachability of this next hop. If the next hop is failed, that means this static route will not work anymore. Then the next static route will take over as a backup. So as you know that just now we mentioned about the floating route, right? So we have this number 5. We purposely put here to increase the AD value to make it less preference than the other route. So if let's say the track A detect that the reachability is failed, so this route will no longer be valid, and then this one will be taken over. So I will just do a quick demo here. Okay, just now we already configure from 1 to 4, right? So what we need to do is from the router 1, we will add on another route that going to the destination, but go through the R3 as a backup route, right? IP route 10.1.1.1 to 55. And the next hop, we are pointing to the R3, which IP address is 30.1.1.2. With the higher AD value, we put it 5. Okay, until now, let's verify the route. So we still have 20.1.1.2, which is our R2. I can show you the static route command here. Okay, we actually have how many route? Oh, okay, this one we need to, by the way, we need to remove this. Okay. Okay, now we actually configure 2 route here, but in the routing table, you can see that actually we only have 1 route, which is the 20.1.1.2. We have a lower AD value, right? So we need to configure the IP SLA now with the command. Okay, let me pull out the command with this command. Okay, the first we need to define the track A, IP SLA 1 reachability. That means I will track the reachability of the IP SLA 1. So I will define IP SLA 1 and then make the ICMP echo. That means I will actually ping the 20.1.1.2, which is my current next hop. I will use the source IP 20.1.1 to ping. Okay, I define the frequency as 3 seconds. It will be faster because the 3 is defined as a frequency in second. Frequency 3 seconds, so it will detect faster. Okay, oh, cannot be less than 5. So I put 5. Okay, next it will be IP SLA schedule 1 as live forever, and the start time is now. Okay, that means this one will start to do it. See, actually you can see some of the node is coming out. That means the tracking is working. Number A, IP SLA reachability from down to up. That means it's able to ping the 20.1.2, right? You can verify here, ping 20.1.1.2. We are able to ping. So it's actually up at this moment. So the next step, we will need to configure another IP route that with the track A. So let's do show. We are now having this, but let's remove it. Okay. We will put back with the track 8. Okay, the static route is still pointing to 20.1.1.2 as a next hop. So let's do the verification here. I will just go to the interface, this interface, E0/0. I will just use shutdown the interface. Okay, interface will be down. Okay, interface down. R1 will detect the interface down in 5 minutes later, 5 seconds later. Now you can see that it's actually down. Okay, let's show the static route again. Now you see that actually next hop is being changed to 30.1.2. So here is 20.1.2. Okay, so makes sense. So if I make it unshard, so interface unshard, then my R1 will detect that track A is detected the IP SLA reachability now from down to up. And then the next static route will be installed back to the original one. Okay, any question? Let me look at your question. What protocol or configuration required for that? Can it be shown? Suppose we have two ISP and the client has taken private IP. ISP usually won't provide the private IP for you. Now he wants a backup link from other ISP. The private IP is not able to be routed into the internet. So to connect as a backup from other ISP by using the private IP of the first one. To connect as a backup of other. The ISP won't provide the private IP to the customer. So usually you can't do that because of the private IP. Suppose ISP provided, but if ISP provide, the private IP cannot be routed to the internet. So even your ISP can support you to route your in lease line in your, okay, so you provide a lease line for you. You're connecting your own network using the private IP address, right? Okay, so it's a lease line for connecting your private network. You will need to take in the yeah, it's possible. Yeah, it's possible. Because now you are actually defining the private network as your, even though ISP is providing you the link, usually the lease line link will actually be like layer 2 link. So usually you will actually need to do your IP addressing by your own. Yeah. Most of the case, if the ISP provide you the lease line, you actually define the network as a layer 2, and then you will define the private IP by yourself. So this private IP you can route between the two ISP link, no problem. It just depends on your router configuration. Because it's actually a private network, you can just do a routing from one inside your router to route to your ISP. That is possible, but it's also need to depends on your ISP whether your ISP actually have this routing being configured in their end to be used. What routing protocol to be used? Actually, you can use any of the routing protocol as long as the two ISP they actually support each other. For example, let me use this diagram. Okay, you just imagine that this is the ISP1, this is ISP2, and this is your company router, and this is also your company router, right? Then your ISP actually provide this IP address and this IP address for you. But how can this IP service provider 2 that can get the route from this service provider? It depends on whether your router will advertise this IP address from your routing table, pass it over to this ISP. And this ISP also will need to pass over the routing information to this router D. So you will need to configure something like OSPF for all these A, B, C, D router. So it will very depends on whether your ISP can support you to configure this OSPF. Yeah. Correct. So, but in the actual in the actual network or actual implementation, your ISP usually will just provide the lease line for you. It will not do this kind of thing. So most of the ISP will actually doing BGP route, which routing the public IP for you to go internet. Or even you want to do this yeah, usually ISP will do BGP. Okay, any other question? I actually have finished all my demos and my all these slides. So if you have any question about today's lesson, you can ask now. We have a bit over time. Sorry about that. Thanks for your patience to stay until now. I hope most of you are actually listening very seriously, or hope you can get what you want. Sure, we will share the video to you. Okay, if you have any question, you can raise. If you are interested about the lessons today and you are very keen on the next lessons, please feel free to register for the next class. SLA calculation, how it done. For this SLA is not a calculation. It's just that my RA will just use my interface G000 to ping this IP address, right? So there's a define here. I use the source IP .1 to ping the destination .2. So if the ping is failed, because just now I also define a frequency, right? Which is 5 seconds per time. So this ping that means my router A will use this interface to ping this IP address of the router B. Every 5 seconds, I will ping it. So ping 5 seconds, okay. Then next 5 seconds, I'll ping again, okay, again. But if it's not okay in the next ping, so it will straight away to trigger this second static route. Okay. So basically is to monitor whether this because in our static route, right, as long as your next hop is reachable, my static route will be valid. But if the next hop is not reachable, the static route will not be valid anymore. So that's why here is to check the next hop, the reachability here. See, the reachability here is very clear to mention to you the functionality of the check. It's very useful in the actual deployment of the network. If you are doing operation, you may see in your current network have this configured in the router. Okay, any other question? Usually 255 hop, I think. It will ping until 255. Next lesson I haven't decided yet. I need to talk to my colleague. Yeah, so you just follow us and then check what is the next lessons. And remember, if you want to follow my lessons, just remember my name. My name is Leon. Yeah. Every week we will have a lesson ongoing. You just yeah, keep checking. Okay, if no further question, thanks for your time. Thanks for joining the class. See you next time. You will feel free to exit the class. Thank you very much. Sorry about some of the disturb just now during the class. I think that is because of the some of the people's, yeah. Sorry about that. No, you cannot unmute. Okay, see you next time.
I found a love for me, and darling, just dive right in and follow my lead. Well, I found a girl, beautiful and sweet. Oh, I never knew you were that someone waiting for me. 'Cause we were just kids when we fell in love, not knowing what it was. How will I give you up this time? Darling, just kiss me slow. Your heart is all I own, and in your eyes you're holding mine. And baby, I'm dancing in the dark with you between my arms, barefoot on the grass, listening to our favorite song. When you said you looked a mess, I whispered underneath my breath, but you heard it. Darling, you look perfect tonight. Well, I found a woman stronger than anyone I know. She shares my dreams. I hope that someday I'll share her home. I found a love to carry more than just my secrets, to carry love, to carry children of our own. We are still kids, but we're so